Today we are going to be comparing rational numbers in different forms. Our first example is 9.02 and 9.2%. To be able to compare these, we need to make it fair to compare, which means they both need to be in the same form. Right now, we have a decimal and a percent. The easiest way to compare these two numbers is to turn them both into decimals. To turn a percent into a decimal, you need to divide it by 100. So when we do that, we get 0.092. The first number, 9.02, is already a decimal, so we're going to leave it alone. Before I compare numbers, I like to make sure they are fair to compare. 0.092 has 3 digits after the decimal. 9.02 only has 2 digits after the decimal. So I added a 0 to the end of 9.02 so that it is fair to compare. When comparing numbers, I first like to look at the digit or the number in front of the decimal point, the whole number. In this case, we have a 9 and we have a 0. Since these numbers are different, we can actually use these numbers to compare. 9 is greater than 0, or 9 is bigger than 0. So I need to use the greater than symbol. Since 9 is bigger than 0, we use the greater than symbol for this example. Looking at the next example, we have two fractions. Both of them are negative. To compare fractions, especially when the denominators are not the same, I like to turn them into decimals. To turn fractions into decimals, you divide the numerator by the denominator, or 3 divided by 5 in this first situation, and 13 divided by 20 in the second situation. When I divide 3 divided by 5, I get 0.6. Notice that 3/5 was negative, so I've brought down that negative to negative 0.6. Do not lose your negatives. 13 divided by 20 gives me 0.65. Again, that fraction was negative, so do not lose your negative. Make sure you keep it with the decimal version of that fraction. I notice that my second decimal, 0.65, or negative 0.65, has 2 digits after the decimal. Before I can begin comparing these numbers, I need to make it fair to compare. So negative 0.6 only has 1 digit after the decimal, so I add a 0 to make it fair to compare. I've made the note that bigger negatives mean they are smaller numbers. That means the more negative a number is, the bigger into the negatives you go, the smaller the number is. So I need to take a look at my whole numbers first. Both of these whole numbers are 0, so that's really not going to help me compare them. So now, since that is not able to be compared using 0, I'm going to look at the digits and the numbers after the decimal point. I have a negative 60 after the decimal point and a negative 65 after the decimal point. The bigger negatives are smaller numbers. So I notice that 65 is a bigger negative than 60, which makes negative 0.65 the smaller number and negative 0.60 my bigger number. I need my greater than symbol. So negative 3/5 is greater than negative 13/20. Both of these numbers are decimals, so I took a look at what I was given, and I had 6.050, and then I had 6.05. Before I can compare, I need to make them fair to compare. So I had 3 digits after the first number and only 2 digits after the second number, or after the decimal in each of these numbers. So I had to add a 0 after the decimal in my second number to make it fair to compare. Looking at them, every single digit, including the decimal point, is exactly the same. That means 6.050 is equal to 6.05.